Today we will continue with the data modeling part. So data modeling, I think it is a new topic for you all, except one or two. Okay, so it's a new topic because in Power BI you should be knowing how to do the data modeling. You have to do the data modeling. If you don't do the data model design, you cannot get the accurate. The reports will not have the accurate values in it. Okay. Since data modeling is very much important, without data modeling, the filtering cannot be done. Okay, so this specific to data model is not specific to Power BI. It is one this is one of the important tasks that needs to be done. Once you are done with the requirements gathering, at the end of the requirements gathering phase itself, they will start do the high level design, high level data model design. They will be doing it, which is nothing but the conceptual data model, and then logical data model, physical data model. They will be doing it. Okay, this is irrespective of the tool. Data model is one of the important tasks because without having a solid data model strategy in place. One second. Yeah, without having the solid data model design in place, if you build any application or any applications or any software, right? It will not have you cannot have the proper you cannot achieve the proper output. In the case of Power BI, it will not do the filtering. Okay, hence data model design is very much important. But when it comes to Tableau and ClickSense, you don't have to do the data model design. It is taken care automatically. Even in the case of Power BI, once you load the data into Power BI desktop, it automatically detects the relationship between the tables, and then it creates the relationship. But still, it is our responsibility as a data architect. You are supposed to check, whether the relationship created between the tables are correct or not. You need to validate it. One way it is good, you are adding additional skill set to your profile. If you learn Tableau, you don't have to learn data model design. But in this case, you will be learning data modeling also. So first of all, what is a data model? What is a data model? Is something like the architect's it's an architect's blueprint, right? It will be compared to a roadmap or an architect's blueprint. So here what we do is we find out the relationship, we create the relationship between the tables. Okay, or in simple term, it represents the framework of what the relationship or within a database. Tables are there. Okay, we have different tables. We don't store all the data in a single table. We decompose the tables into we decompose the tables table into multiple tables, and then what we do is, for example, to store the customer information, we create a separate table to hold the customer data. Similarly, product and category and store and region related data, date data also we have to store it in a separate table. Transaction related data, we store it separately. We don't store everything in a single table. Okay. The reason is performance and also filtering is possible if you store the data separately. Okay. So like I said, data model can be compared to a roadmap or architect's blueprint. As part of this, we define the relationship between the tables or amongst the tables. For example, I have a customer table. Okay, so what is the relationship between the customer and orders? Customer places the orders, and then the orders in the customer places orders. What do they order it? Products, and then products falls under different categories. Right here, there is a relationship here. When a customer orders products under different categories across stores, which stores they are ordering it. Okay, which store are they ordering it? and which region are they ordering it. Okay, so and which brand are they ordering it. Okay, so you have products, same products is available across various brands, and those brands, obviously it will fall under single category if it is a similar product. For example, you want to buy a hair dryer, you have different brands are available, but hair dryer falls under a specific category, electrical items or something like that, or home appliances, electrical appliances, we can say that. Though a hair dryer falls in electrical appliances, within this hair dryer category, if you see within this product, different brands are, again, you have another table wherein you store the different brands data. Okay, there are three types of data model. One is the conceptual data model, other one is logical data model, physical data model. As you are aware, in the case of conceptual data model, we will identify. So when you during the workshop, when you conduct any workshop, right, as part of your requirements gathering, what you will find out, what are the entities that are required to to meet their reporting requirements, or to answer their business questions, different stakeholders business questions. What entities are needed? Entities are nothing but the tables, the time, product, sales, store. Right? So in this case, obviously, like I said earlier, right? So the customer places orders, and each order, you can see different products. Different customers order different products, sometimes same products, but they order it across the stores, the different stores. Okay, and these are the entities are required to capture a specific event of each and every event of the orders, right? As and when they raise the new order, we need to capture the data in various tables. The data behind the scene will get stored in different tables in the case of OLTP system. So what they do is they make sure that what are the tables that are required. Not only, it is our response as a business analyst, it is the responsibility of finding out the tables are sufficient, but also they need to find out the relationship, how each tables are interacting with each other. That is very important. As part of the conceptual model, while talking to the customer, they will get to know the relationship between these two things. And you can see the crow's feet here. Just above the crow's feet, you can see the circle, right? Zero or many, right? So here the time and product, right? So many-to-many relationship or one-to-many relationship. That is what this one tells us, the crow's feet and the zero, right? So products may be ordered, sales happen in zero or more store. Okay, some store there are no sales at all, right? So some maybe in that specific region or specific city, due to riot, they shut down, hence there are no orders. Zero or more sales or orders should have been raised by the customers, and they would have purchased zero or, here it's supposed to be one or more products would have been ordered. It's not zero, right? Yeah, customers, yeah, we can say zero or more. Sometimes not all the products would have been purchased, right? So zero or more products would have been, but zero products we cannot say. Yeah, it will be like a one to many. So one to many, and time also one to many. So basically we wanted to find out the relationship. It is also called as a cardinality. The relationship is also called as a cardinality. As part of the conceptual model, they'll identify the entities or tables that are required. What are the tables that are required, and how those tables are having a relationship, interacts with each other. And next one is the logical data model. In the case of logical data model, they will find out the attributes that are required as part of each and every table. Okay, so knowing the table alone not sufficient. What are the columns are available, attributes or columns, all these terms are seen. So in the case of time table time, so what columns are required, and product, what columns are required, sales, what columns are required, in store, what columns are required. Okay, now we identify the columns that are required as part of each and every table. The next step is a physical data model. In the case of physical data model, we define the data type for each and every column and the width of the columns. What should be the width of each column? We define it. And then what they do is they will so once you create the physical model, or each and every phase, right? Conceptual data model, you document it and share it with customer for their sign off. And then once they sign off, you proceed with creating the logical data model. And each and every phase, conceptual model, logical model, physical, you get a sign off from the customers. Once they wait it, everything is good. Then you will go and physicalize it. You create the tables. So in the once your physical data model is ready, in the sense all the tables, all the columns and data type and width, everything is, everything is verified and signed off by the customer. You go and create the tables in the database. Okay. So this is what your physical data model. Look here. So date ID, integer, date, description. But when it comes to any analytics project, the date or time dimension is required. There is a separate table you need to have it in order to capture the date related information. Inia will discuss about the date dimension probably a little later in today's session, or tomorrow we'll discuss it. Okay. So product dimension, fact, sales, and store dimension. And here you can see the data type and then width. For example, store description. So what is the width? Varchar of 50. Okay. And here 30, 30 and all. Okay. So now the question is why we have to do the data model? Is it really required? So to answer to this, I will have to jump into the Power BI desktop. Let me just launch the Power BI desktop. Okay. We'll start the Power BI desktop. If you don't create the data model design, what will happen is it will not do the filtering. Look here in this chart on in the x-axis, we have something like a month name. Y-axis, your sales amount. For all the month, it shows the same sales amount. It is not doing the filtering. This one comes from the date dimension, the English month name, and then the sales amount comes from your fact sales or the transaction table. In this table, the date dimension should filter your sales transaction table. Not do the filtering, relation should be there. In this case, the relationship was not defined, hence it was not at all filtering it. Okay, my desktop, Power BI desktop got launched. Here, just close this. And when you go to the get data here, you can load the file from a text CSV, not CSV, and I load couple of files here, Excel files, sales fact. I just load it, and then in this sheet, we have two subsheets are there. We will go and check which subsheet we needed. This is the one we needed. And I just hit load. So now what will happen is the data will get loaded in the name of that subsheet, NC sales. You need to rename it so that it will identify which data file this data be loaded here. And the next one is I just load one more file. I just say dim location. Yes, dim location. Transform data, because there the column names were not displaying correctly. Go to transform and sorry. And here use first row as it is. Yes. Location key, location name. And this is the one. Here I just rename it as sales fact. And then the next one is your location dimension. Okay, your tables are ready. As I said, irrespective of the type of the file you load the data into your Power BI desktop, it will consider them as a tables. Consider them as tables. Look here, this is a table and dim location. We have renamed it with proper name for these tables. And next, what I will do is I will just apply this. Now we will go and take a look at this model view. So far, we did not go to the model. We did not spend much time on the model view. So in this data modeling topic, we will be spending more time here. Look at model view. I'm going to click on this. You can see that a relationship, the link, this is called a relationship. Okay, the relationship got created between these two tables automatically. A line has been, I did not do anything. It created the relationship automatically between these two tables. This line tells us there exists a relationship between these two tables. And what kind of relationship? On this table, next to this table, you can see one here, and this table, next to this table, you can see star here, which means one-to-many relationship. There exists a one-to-many relationship between these two tables. Okay, this is a dimension table. This is the fact table. And you will discuss about star schema a little later. Don't worry. Okay, at this moment, you think the dimension tables and fact table. So in general, you will have more dimension tables. In fact table, you already have one or two fact tables will be there in in each subject area. For example, you have finance, and you want to perform finance analytics. The finance is a department. So there, we call that as a subject area, finance subject area. When it comes to holding all the tables that are related to financial analytics, you will hold it in a separate schema in your database. We call that as a subject area, finance subject area. That subject area, you keep all the finance related tables. So even the financial analytics related tables, even in that case, right, you will have fact table and dimension tables. At the max, you will have one or two fact tables will be the dimension tables will be more. And here, in this case, one fact table, one dimension table. For demonstration purpose, I've used only these two tables. I just go to the Power BI desktop. Before that, sorry, the report canvas. Here, if you hover the cursor, if you keep the cursor on top of this, you will get to know that the location key is the column got highlighted between these two tables. Location dimension table, we can see location key, and sales fact table, we can see the location key got highlighted. That means these two columns are common between these two tables. You need to have the common column between the two tables, so only then you can create the relationship. Since the common column between these two tables are location key, it creates the relationship automatically. In case in this table, instead of using location key, if you give something like location ID, Power BI will not identify. It will think, these two are different table columns, and there are no common column between these two tables are existing, hence it will not create the line. But the naming standard should also be followed here. Let's say in the sales fact table, already they mentioned location key. The same naming standard, they use it in the dim location also as the location key. But in the real world scenario, not all the time it will be same. Okay. We need, so in that case, what it will not create the relationship. That we will see later. Okay. So first we'll start with understand. So look here, when I hover the cursor, the columns between common column between these two tables got highlighted. With the help of these two common columns, we are, it was able to create the relationship. At this moment, you remember this. Now I just switch to the report canvas view. And what I do is I will just select any one of the visuals here. I just select the clustered column chart. And here what I do is, in this case, I will expand the sales fact and location name. What I will do is I will bring in the columns from these two tables. See, first of all, why we need to create the relationship between these two tables? Okay. The reason is, in this table, we have location keys available. And let's say if the business question is something like, we wanted to see the sales breakdown by location name. If you give the location key, that is not helpful. They wanted to see the sales breakdown by location name. The location name is not available. It is available here. To answer to this business question, you need to bring in a location name column from this table, sales amount from this table. These two columns are coming from two tables. In order to bring in these two columns from two different tables, you need to have the relationship. You need to define the relationship. Here, what I do is I just selected this visual. Just now I clicked on the clustered column chart. What I will do is I just drop the sales amount. And then I just go to the location dimension. I drop the location name here. You can see that the city-wise, location in Chennai, Delhi, Hyderabad. So what is the sales in each city? Chennai 4,05,000 and Delhi 21,000. Okay, we can see the sales detail here. So it is doing the filtering correctly. If I select this visual, I just drop the columns from these two tables directly into the visual. And at the same time, if you see here, right, what columns dropped in which axis, you can see it here. Location name, sorry. Location name comes from, the x-axis comes from this one, this thing. And then the y-axis is sum of sales amount. Location name and sum of sales amount. You can see it here. These two columns are coming from two different tables. Remember that. On top, if you see here, when you hover the cursor here in the y-axis, sum of sales amount, when you hover the cursor here, you can see that the sales amount comes from sales fact table. Sales amount comes from sales fact table. Location name comes from location dimension. All right, so this is what we can see it here. But if you notice here, the sales amount, I just dropped it here. It automatically becomes sum of sales amount. I did not do any sum here. And as I said earlier, once you load the data into Power BI desktop, for the numeric data type columns, you can find, just before that, you can find the sigma notation. Right. So by default, it performs an aggregation. When you drop, see, for example, you drop any numeric column into a visual, it does the sum automatically. Aggregation. The default aggregation function is sum. If you remember these things at this moment, that is enough. Okay. The location name and these are. So in this case, what happened? The location name comes from the dimension location. This comes from sales fact table. The location table filters the sales fact table. Okay. For example, if I go to the data model view and if I delete the relationship, look here. This is what I was talking here. Why the data model is required. That in order to perform the slicing and dicing, the relationship is important. If you don't define the relationship between the tables, the slicing and dicing will not happen. So in this case, the dimension table needs to filter the sales fact table. Only then it can show the correct output here. Now it is showing, since there are no relationship exists between these two tables, it is not showing the accurate value. All the city value, location values, if you see, everything is same here. Hence, it is mandatory, to have the relationship between the tables. Okay. So now how do I create the relationship between the tables? You just select the columns, common columns, right? For example, in this case, I just take this location case, select this one, and I drag this and drop this on top of the location key column name itself in the sales fact table. You need to wait for some time. It will automatically create a line, right? So one-to-many relationship. It automatically deducts the cardinality also. Whether one-to-many or many-to-one, it automatically deducts that. The location, so the dimension tables are also called as a lookup table. You need to remember, these terms also. Okay, understanding these terms also very much important, because the real world scenario, they'll be the project status and all, right? They'll talk about, they use different terms. Some may call it as the dimension table. Some they call it as a lookup table. But there are people, they still call it as a master table. Okay. Please give me a second. So this is also called as a lookup table. Lookup table. The location table is also called as a lookup table. But in the case of YLTP, they call it as a master table. When it comes to analytics, usually we use the dimension. We use this, we represent the lookup table with the name of dimension tables. It is also called as a lookup table. Remember this. So now I create the relation between these two tables. Let's go and see. Now you see the filtering is happening. Okay, what is happening is when you create the relation between the tables, the location key from the dimension table flows down to your fact table. Okay, I just go and show you with other slide. Look, this is what is happening. Let's take this example. This is your dimension table, country, customer. Sorry, this is your country dimension. And this is your sales fact. You just think that way. Let's say your manager wants to see the country-wise sales performance. United States, for example, Australia, and how much sales we made, right? So the total sales, country name. So country name is available here, and then the sales is available here. You need to bring in these two columns from two different tables. Hence, it requires a relationship. In order to create the relationship, you need to have the common column between these two tables. Obviously, country ID are the common columns. Hence, you create the relationship between these two. Here you have this table have one, this table have many values. For each country, more than one entry you can find it here, one-to-many relationship. Okay, so in this case, what happens? What do you mean by filtering? In the country table, first it goes to this record, first record. Okay, so what happens is you have created the relationship between these two tables based on the country ID. The first record in the first column value, US will be propagated to this table. It will be sent to this table. And then what happens is, once upon receiving this value US, the sales fact table, it automatically applies a filter where and all US records are the transaction. It will highlight, it will select those records, and then it applies the sum. In this case, sum aggregation function, we are using it. So it will apply the sum on these values. Supposing you want to see the total units sold in USA, so this is what is in 10 plus 6, 16 plus 2, 18. Total units sold is 18. Similarly, it sum all the sales values. And then what happens is, okay, US, let's say you have some total value, sum of value is 8,000, 12, 19, 21, 22,000 and odd, okay? And total sum of sales values. Australia. Next one is, next it goes to it moves, skip to the second record, Australia. This AU will be passed here. Okay, it will be propagated here. And once this one gets propagated, automatically the records that have AU in the country ID column will get filtered. And then it applies, it's kind of a grouping, okay? It applies the sum on these values. Next one is Australia, right? So Australia, it did this thing, okay? And similarly for Germany. So Germany, we have two records are there. It filters. It propagates the value from your dimension table to your fact table. And then it applies the filter. This is what is filtering, okay? It propagates the value from your dimension table to fact table, and then it does the filtering. The next step is, once it has been done the filtering, it applies the aggregation function, sum or average, something like that. That is what is happening here. That is what is happening here. The location key will be propagated to this table, and then it does the filtering. Without the relationship, it cannot do the filtering. So now you understood. So why relationship is important, why we need to create the data model design. Now with this, you are able to understand. Without data model, it cannot do the filtering. So relationship in Power BI means filtering and the ability to slice and dice a table by another table. Without relationship, we cannot filter the data across tables just by itself. Next, we'll take a look at the star schema. This is your star schema. Look here, you have customer, product. Let me just take this example. Yes. The promotion, currency, sales territory, customer, date, product, all these tables are your dimension tables. The middle one, the internet sales, is your, look here, this is a classic example. Yeah, the dimension tables, all this is your fact table. This fact table is surrounded by more than one dimension tables. So the idea of the star schema is to keep all numeric values in a separate table called your fact table. This is called your fact table. The middle one is the fact table. You keep all the numeric values here and put all the descriptive information into your dimension tables. Okay, put all the descriptive information to other tables. Those other tables are called dimension tables. Usually the fact tables are surrounded by the dimensions. These dimensions helps us to explain the facts that you store here. Facts are nothing but the numeric values. Right, as you can see here, the fact table we can see in the middle, and it got surrounded by the dimensions. So it looks like a star. So hence it is called as a star schema. Okay. Okay, the keep all numeric values in a fact tables. Yes, keep all descriptive information and surrogate key into other tables called dimension tables. These dimension tables will have the surrogate, the primary key. In this case, the currency key is the primary key, and the promotion key is the primary key. Here, customer key, date key, and territory key, sales territory key. These key columns are nothing but your primary key column. It is also called as a surrogate key in Power BI. Okay. The dimension tables are joined to the fact table using the foreign key. See, this dimension table, the fact table will hold the dimension keys of all the tables, key columns in it. Along with that, it will have the numeric values. To put it in simple terms, fact table will hold the dimension keys of all your dimension tables plus the numeric values. For example, freight charge, the extended amount, discount amount, and the sales amount. These are the example for measures or numeric values or facts. It is also called as a numeric values, also called as facts. Okay, and along with the key columns, you store the numeric values, which is nothing but the facts in it, which are nothing but the facts. Okay, but storing the key alone not helpful. Like I said, if I wanted to see the territory name, I want to see the sales breakdown by territory, by product. You need to join this table with these dimension tables, territory and product, in order to answer to this business query. And then do a lookup here and take the territory name from here and product name from here. And then so display this well. If I say something like how many units sold, let's say the unit sold was 100, and this is my unit sold. And then the sales, okay, for this unit, how much we made? Let's say 100K. If you say 100 units sold, sales 100K. And if you say okay, so what is this? You need to give some context. To give context, what we do is this one is held in this fact tables. To give the context to this one, what is this numbers? Okay, fine. Units sold, this much units we sold, and this is the sales amount. And can you give me, what this one is all about? This is related to which product? Is this related to product, or is this related to product by sales? Sorry, territory. So in that case, you need additional table, but in this table, you are storing only the key column, territory key and the product key. But they need the product name and then territory key. If you say T801, in the case of Walmart, right? So they have the retail chains scattered across the globe or within the country itself. You can see a lot of retail chains are there. T801 belongs to which location? What is the store name? We do not know, right? Territory name, we do not know. And the product key is, let's say, AB 5080101. If we say something, what product is this? We do not know. But these informations are available in the fact table. This is your dimension key. This is your facts. In order to get the context for these values, you need to take this key, pass this key, propagate the key to your territory table. And then you need to propagate these values to this product dimension table to get the product name and then territory name. That's it, guys. To provide context to the facts, you need to join the dimension tables with the fact tables with the dimension tables. So the key columns are used here as a foreign key to create the relationship between or to join the tables. You need to maintain the foreign key in your fact table. With that, you do a lookup on the respective dimension tables to get the the facts. Okay, to give the context to this, you need to do this one. Got it? So this is what your star schema. Okay, to summarize, to keep all numeric values, we use a fact tables, and to keep all the descriptive information and surrogate key into other tables are called your dimension tables. And then the fact tables are surrounded by dimensions that explain the facts. Okay, the dimension tables are joined to the fact table using a foreign key. The dimension, if you see the dimension table, they are not joined to each other. We don't see any relationship between the dimension table. Instead, all the dimension tables have a relationship with your fact table only. Next one is the Snowflake schema. This is an extension of your star schema. If you look at this data model, the dimensional data model, if you see here, it is similar to your star schema, But if you look at these three tables, the dealer, location, country. Here, instead of keeping all these three values into a single dimension table, they decompose the single dimension tables into three different dimensions. Why? Because storage, they can, to avoid the redundancy, they splitted this single dimension table into more than one dimension table. Here they store all the country related information. Here they store the location dimension, dealer dimension. Okay, since we are creating the additional dimensions, right? It represents the kind of hierarchy, right? So the location, like each country have the location in that. So for example, something like this country, if you put it like this, location, and each location you have different dealers, right? Dealer 1, dealer 2, etc. To create some kind of hierarchy, you can go with this kind of thing. The advantage of this one is Snowflake Schema, it requires less storage space. Okay. And also due to multiple tables, the query performance is reduced because you don't store the data redundantly. But the issue with the Snowflake schema is you will face the challenge. What you will face while using the Snowflake schema is you need to perform more maintenance efforts because of the more lookup tables. Okay, but so what Microsoft recommends is use the star schema wherever it is required. Okay, in the case of star schema, you denormalize these three tables and keep all these data at a single table. Instead of joining multiple tables, you store it. But even though there are redundant values, keep everything in a single table. All the dimensions. Don't decompose the dimension tables into multiple tables. That is what the star schema model is all about. Microsoft also suggests us to use the star schema. But the advantage, so with Snowflake schema, there are some advantages, but disadvantages also there because you need to join multiple tables. For example, if you wanted to find out the units sold or the revenue by location, these two tables are not directly, related, the dimension fact table. Okay. And if I ask you the sales by country, by location, by dealer, you need to join multiple tables. Okay. Or if I ask you country by sales, so what will happen is you need to navigate to this table, and for, this table is filtering this table, and then only this table is filtering this one. Okay, so to get the country by sales, right, you need to have these two tables because you cannot directly, you cannot use only these two tables. To navigate to this table, right, you need to via the dealer table. The navigation has to happen via the dealer table. In this case, even though you wanted to see the sales breakdown by country, you need to use this table also because only these two tables got filtered, and this table is filtering this table. This table is not directly filtering this one. Okay, there will be a redundancy in terms of importing the tables, and also the joins. It requires joins to multiple tables. So that is the difference between the Snowflake star schema and Snowflake schema. Next one is the fact table. This I already discussed as well, the star schema and Snowflake schema. The fact table contains measures or the items to be aggregated of a business. So what do you mean by measures? It is also called as a facts. And these are the examples. So these are the numeric values are nothing but the measures or facts. The data in a fact table should be sliced and diced by the data of dimension. The fact table has a many-to-one relations to every dimension. Look here, many. So this is one side, this is many side, one side, many side. Measures are usually sliceable. Okay. In order to slice the measures, you need to have the relationship. So simple term, the fact table would contain key and measure. If somebody asks you, what is the fact table? Fact table will consist of the key plus, what do you mean by key? The dimension keys from all the tables plus the measure or facts. different types of fact tables are there with the transactional fact table. So all the transaction, day-to-day transactions, you will capture it in your fact tables. That is called your transactional fact table and periodic snapshot. So every once in 15 days, I wanted to capture the data in some table, and some tables accumulating snapshot fact table kind of aggregate the values every once in a week, aggregate the data and then store it in your other fact table. So that in your visual, if you wanted to see the sum of sales by region, by region, by store, by category, since you already aggregated, it will display the values, or it will render the visuals in a pretty faster manner. There are cases you have factless fact table. It's kind of a bridge table. As the name suggests, you will not have the measures in it. Okay, only the table only will be there. In that table, you will not have the facts in it. The measures, it will not have it. It will serve as a bridge table. In the case of many-to-many relationship, you will have this kind of table. The classic example for this one, this is the one, salesperson and region. More than, right? So one to many. So each salesperson may work in more than one region, and each region may have more than one salesperson. In this case, you have these two tables, you don't have any relationship. You cannot create any relationship because there are no common key between these two tables, first of all. Okay. So what you do is you introduce a bridge table in between. The key column from this table and the key column in this table, you will keep it here. Okay. So in this table, you will find the foreign keys for these two tables. Okay. And the salesperson key is a foreign key and territory key is a foreign key. And here you will find the salesperson key appears more than one time. The territory key also can appear more than one time. But whereas in this table, the salesperson key should appear only one time. There should not be any duplicate for salesperson key, as well as there should not be any duplicate for the territory key in the region table. Okay, these two are kind of lookup table. Why we call it as a many-to-many relationship? Because in this table, salesperson key appears right more than one time, and here it appears more than one time. The territory key here. If you have if the key columns have more than one value in both the table, you cannot create the one-to-many relationship. If in order to do the filtering, you need to have the one-to-many relationship. So how do I handle this kind of situations? You will introduce something called bridge table. Here, these two tables have one-to-many, and these two tables have one-to-many relationship here. With this, we can resolve the many-to-many table relationship. In the intro, they'll ask you, remember this, okay? Next one is the type of relationship. What are the types of relationships are there? The types of relationships is also called as a cardinality. So you have, so first of all, what is relationship? It's nothing but filtering, okay, or cardinality. Cardinality is nothing but relationship is nothing but the filtering. There are, 4 different cardinalities, types of cardinalities are there, or the relationships are one-to-one, one-to-many, many-to-many, and many-to-one, okay. So what is the example for one-to-one? One-to-one is pretty straightforward. For example, SSN number. In US, you just think about the SSN number. Each citizen should hold Each citizen should hold only one SSN number. Okay, and the SSN number should be assigned to the unique SSN number should not be duplicated for each citizen. It should not be duplicated, and each citizen should have unique SSN number. So this is one-to-one relationship. Okay, one-to-one. Next one is one-to-many. You have something called, this is your fact table. This is your dimension table. Here, it will have one-to-many relationship. What is the example one-to-many? Let's say a single employee working in multiple projects. In a software company, if you see a single employee is working on more than one project also, this is called your one-to-many. This is one example. And your other example is a single customer can order more than one item, more than one order. Another example is the car manufacturer produces many cars. A single manufacturer can produce multiple cars. This is one-to-many relation. This was the example for that. And many-to-one, the opposite. Like I said here, this is your employee table. This is your project table. In this case, each employee is working on more than one project. But there are cases, yeah, so and also the opposite is true, right? So sorry, the employee, we cannot use this one. We'll say the manufacturer. Manufacturer, a single manufacturer produces multiple cars. Okay, here in the many-to-one employee and projects. A single employee is working on more than one project, and each project, multiple employees are working on it. Each employee is working on more than one project, and each project have more than one employee. Okay, that is what your many-to-many relationship. The many-to-one is the example for that one is this one. 1 second, sorry. Many-to-one is each employee. So each project will have, see in this case, the opposite. You put the project here and then you employ here, right? So each project, multiple employees are working on it. That's all. The opposite of this one. One-to-many, many is the opposite. This one is many-to-one. Many-to-many is this one. Each employee is working on more than one project. Each project have more than one employees in it. Now we understood what is one-to-one, one-to-many relationship. Lookup dimension tables are also called as the lookup tables, and the data tables that are called as the transaction tables are called your fact tables. The fact table captures all the transactions. Lookup or dimension table carries all the filtering information, or it holds the descriptive information about your facts. So what we will do is, again, I will start next. We will look at the active versus inactive relationship. This one will continue in tomorrow's session, okay? Because most of you are non-IT people. You just watch my today's video and try to understand. And tomorrow's session, we will proceed with understanding what is active and inactive relationship. This is specific to Power BI, okay? Any questions so far? So this one, I don't think so this is required, right? So I don't have to send this one. What you do is you just give it a try on your own. If I send everything and if you use my report file, what you are going to learn. Hence, I'm not going to share this file. Watch my video and practice it today, okay? And again, I did not use much, only 2 tables you need to import it. These 2 tables are available in my zip file. In my website, okay? Download this, already explained you where to go and download and practice it, okay? Any questions? Okay, since you don't have any questions, I'm going to wrap up the session now and we'll circle back tomorrow same time, okay? See you all in tomorrow's session.